be tanks. That seems to be the theme of things these days. But I will give it up for Ken White. Thank you very much for joining us.
Appreciate it. We have good levels? Yeah? All right. All right, I appreciate it. So I wanted to talk to folks about some of the work that we've been doing for the last year or so, and hopefully, put some thoughts out about how we can sort of make the core internet infrastructure stronger and more trustworthy. But that's really the thrust of the talk is trust and sort of the core technology stack that's running on the internet, and sort of re-examining that. So let's dive in. So this is me. I'm Ken White on Twitter, and I'm working with some amazing people on this OpenSSL Audit project, which I co-founded with Matt Green. I think most people know the OCAP work through the TrueCrypt audit that we did. And just a quick background. So we formed, it was originally just a small crowdfunded thing, and it sort of grew. We ended up doing way beyond our wildest expectations in terms of global support and the community that came out and supported the work around the TrueCrypt audit. We have an advisory board that's just an amazing group of people. So I think a lot of folks know people like Matt Green, Moxie Marlinspike, some of the privacy experts like Jim Denaro and Marcia Hoffman from EFF. But really encourage you to take a look at the website. It's an amazing group of people that I've had the privilege of working with. And so our focus is on software security, on cryptography engineering, and a little bit on training and sort of public awareness. And our main project right now is the OpenSSL Audit. So kind of, where are we right now? So we're about a year post-Heartbleed. And as much as the tech press, and I think a lot of us in the community talk about crypto sometimes, it's probably worth reminding folks that the most serious vulnerabilities rarely are about crypto. They tend to be about fundamental software failures. That said, we have a really fragile trust chain, and by that I mean everything from the technology stack to the public certificate authorities to really global internet connectivity. And this is one thing I really want to make a point of, that even people who have worked with, say, Linux or on the Microsoft side for a decade, I think a lot of us really don't know what's under the hood. And I'm not talking about people that do like malware reversing and things. I mean system admins, sysops, folks like that. And so I want to spend some time talking about this. And so these are just some questions that sometimes I talk to C-levels or people that are responsible for sort of large organizations. And they're simple questions. How well do you know the network stack you've got in place? How about your technical staff? And do they really understand your core dependencies? It seems like a straightforward question, but when I push a little bit, here's a simple sort of threshold. Explain the dependencies of the Linux init system, or system D. Like, not talking about, a really large global CDN deployment with, lots of clusters and things. I'm talking about a simple, minimum installed Linux web server. Like when you boot that up, what are the processes that happen? What are the dependencies? If you've ever, if you're really into Linux engineering and you've done something like Linux from scratch, I think you might be more familiar with this. But I think you're going to see a number of libraries and things that you may be familiar with, but it might be surprising where their technical dependencies lie right now. So I had an interesting conversation a couple months ago with a guy that's sort of in charge of sysops for a pretty good-sized Microsoft shop. And he ran about 200 or so SQL Server clusters and was responsible for a pretty important system. And we had this weird conversation where it was like 10 minutes into it before I kind of realized we just weren't really speaking the same language. Because anytime we were talking about the work he did and the work that I did, and I tried to explain a little bit about the core infrastructure initiative and some of the work that we're doing on the Linux side on open source. And I just sort of got this vibe that, he was sort of dismissing it. And I was like, well, so what do you, what's your concern? And eventually we got down to, he sort of had this idea that open source systems and software weren't really, quote, enterprise ready. And I don't really know what that means. And so I literally had the guy whip out his phone and say, well, when you've got a VPN client on your mobile, right? Yeah. Well, pull that up. Tell me again about open source versus proprietary and closed systems. And look again. So libcurl and OpenSSL, these are core parts of Cisco's stack in many places. When Heartbleed broke, I want to say it was like 9 days, before they could even enumerate all the systems that were affected, all the systems that had pieces of OpenSSL libraries in them. That's kind of amazing when you consider the R&D and resources of a group like Cisco. I can tell you that a year later, there is an enormous amount of investment going on in some of these bigger companies, and I think folks got kind of a rude awakening with Heartbleed. But even so, if you even I think folks in this room that follow exploits and vulnerabilities from week to week, you know this, but it's worth reiterating. When you do have and I'm not picking on Cisco, it's just, it was easy because it was recent. But when you have things like, $80,000, $100,000, $120,000 core telephony equipment that's, completely on the soft underbelly that's trusted, and it's got hard-coded root SSH keys burned in, which can be, exploited from the outside. And so, about a year, I think it was around May or so of last year, we got contacted from the Linux Foundation because a lot of large organizations, not just sort of traditional Fortune 50 companies, but some of the participants are Amazon and Google, Juniper. I think even Microsoft is a member now. HP, some of these really large tech players. They really got the message, and then when I think it was a month or two after Heartbleed, shell shock broke out. Well, a CIO or even a CISO that's been removed from the front lines for a while may not have their hands on the pulse of the latest libraries or whatever, but they do understand this. The $100,000 commercial load balancer, if I change the name of my browser string from Firefox version whatever or IE whatever to that, I own it. Because a process is inherited and an environment variable that eventually is executed, and this is 20-year-old software at the core of some of these things. And so it's not that people haven't looked at it, it's that in many cases, there's been no real disciplined analysis of some of these crucial utilities. So let's really look at the whole security chain. How many people know libxml? If you do any development, right? It's a requirement of the kernel. It's a requirement of the Ethernet stack now. Let's walk through that. How many in this room, by show of hands, have ever heard of libIDN? I see one. It's internationalization library. So what happens? Let's walk through that. So what happens when you bring a server up? And very simple. Minimal install Debian, Ubuntu, Cent, whatever. One of the first things in that process is, we either do some discovery on the network, or we advertise, and part of that includes the fully qualified domain name, or at least the root name, right? Well, what if it's not Latin characters? What if it's now Unicode? Well, now just to even understand the network you're in, you need a full internationalization library. So we did this exercise about a year ago with the Linux Foundation, where we went through and literally looked at the dependencies of the most core executables. And I was seeing these really big libraries, very early on. I was like, huh. So With DHCP, with some of the update services and things, that makes sense, but I think a lot of people, they had no idea. libpng, it's everywhere. It's, it's in Rails and Python, it's in PHP, it's everywhere. Only really in the last year and a half or so, people really began doing the kind of, full path analysis that needs to be done on something that core. On the compression libraries, libz, right? Everyone knows libz if you've mucked around with Linux at all. I mean, it was never designed to be network-facing. It was never designed to be, hostile. That just wasn't in the threat model, and somehow it's ended up that way. And I'm just talking about, sort of mainstream distros and, kind of your, vanilla Apache and Nginx, deployments. If you followed some of the development on System D, so, the newer versions of Red Hat, and I'm not sure, I think most of the mainline distros have adopted it now. In the discovery process, it's actually running a web server to do on-network discovery. So there's a web server that's invoked as part of the boot process in System D. So let's dig a little deeper. How many people use curl, like, fairly routinely, right? I mean, it's awesome, right? It's a fantastic utility. So let's look at it. Curl speaks Samba. Curl speaks POP. Curl speaks LDAP. Did you know that? So that's really useful and powerful, and it's like the Ginsu knives of Linux, POSIX tools or whatever. That's awesome. But that also means that, so that's curl. libcurl, the C wrapper, which then is in everything, includes this as well. And remember what I said earlier? So curl and some of these dependencies are very early on in the boot process. How about strings? People use strings before. It's the idea is you've got a known file, maybe it's binary, and you just want to get the English, human-readable strings out of it and to display. So there's something called libbfd. How many people have heard of that before? Right. It's been around for like 18, 20 plus years in the bin utils. It's used to sort of as part of file type identification. And so when you run strings with no modified flags on it, on an arbitrary file, libbfd is eventually called. libbfd has a number of buffer overruns that you can do, run arbitrary commands. So let's think that again. So I'm doing and I don't mean like a sophisticated, but just a very basic, post-mortem on a simple hack, a WordPress hack or something, and I've got some file. I run strings. There's a very simple sequence of commands that in strings gives a reverse remote shell. What? Huh. These are some of the details. By the way, if you haven't followed him, if you follow these things on Twitter, the handle's LCamTuff. I can't pronounce his name, but he's a senior Google engineer on the security team. Has got an amazing sort of suite of tools called American Fuzzy Lock, AFL. And one of the things that's really cool about it is, besides the traditional, fuzzing options and things, it actually has AI built in. So it does sort of intelligent, pattern analysis and can execute many hundreds of millions of paths, of logic paths. These are things that are, traditionally, a lot of the static analyzers and things are really limited. I can tell you that this tool's in the core suite of some of the biggest tech companies in the world right now, and it's really useful. So that was strings. How about less, right? Like more, less, cat. I mean, everybody uses this, right? In 2005, there was an advisory put out because in some distros of Linux, I kid you not, less is actually a shell script. It's not a binary. It's a big, long bash script. Huh. So I spun it up just to sort of make sure I was not losing my mind. And this is a latest, greatest version of Amazon Linux, ran all the updates and patches. Depending on the environment variable, I think Gentoo but maybe does this by default. When you run less, you're actually running less pipe, which is just, running set UID on a shell script that's a part of most of our distros. I did not know that. And by the way, I don't want to pick on Linux. I mean, this, I spend my world in Bash and on the ops side and stuff. How often do you see this? A bug in Internet Explorer for every version of Windows back to X. We see this from time to time. Part of the problem is code reuse, right? I mean, it's, you've got something that is known and it's useful and it's well characterized. The problem is a lot of things that were never ever intended to have sort of unchecked hostile network input eventually end up there. In this case, I think people followed this a couple months ago, but this was the SMB redirect that went all the way back to XP. So the libbfd, it's, I'm not picking on that in particular. My point is that most Linux admins have never heard of it, and it's sitting on, it's sitting on your core stack. All right, well, let's go higher up. I want to deploy a basic Apache or Nginx server, right? Nothing fancy. I'm not talking about a big cluster. I'm not talking about, a 200 node Docker thing. I'm talking about, just basic HTTPS, that works with most of the, modern web. Well, that was White House Gov like 3 weeks ago. I mean, why isn't this a solved problem? In this particular case, there's an issue with, I think, their CDN, but the point is that, we shouldn't see this level of kind of configuration with presumably organizations that have really deep tech resources. The other thing, too, is I'm assuming most people in here aren't, maybe curious about crypto, but you're not really, crypto engineers. I'm sure if people have heard about sort of the deprecation of MD5 and SHA-1, these hashing algorithms that have some biases and weaknesses. I think a lot of people are sort of like, yeah, but MD5, it's in a lot of places, and we'll probably eventually retire it. So both those images hash to the same SHA-1. Right? How's that possible? It turns out there's an implementation error in the way that the vast majority of SHA-1 is coded, and you can make use of what's called a known pretext attack, or known chosen cipher attack. Is that me? Sorry. Let's see. All right, we'll go forward. So, any people follow the Verizon AT&T story last fall when there was some discussion about super cookies or packet injection? Yeah, I think a few people might be familiar with this. So, for a sizable percentage of North American traffic on Verizon and AT&T on their carrier networks, it doesn't get more simple than this. I open up a telnet session. I telnet, ask for the basic index page, and I get back a unique header ID that's been injected. That's literally the headers have been modified. And the weird thing is, in both carriers' cases, it persisted for like up to 2-3 weeks, I think. I think there was some hand waving about this was an anti-fraud measure or something of this sort. But the problem is, it's not a web server problem, it's a broadcast problem. So even if, and by the way, this wasn't just consumer gear, this was, there was a fair number of enterprise wireless access points, iPads, Androids, et cetera, that got this too. It didn't matter what your client was. It didn't matter what your, browser settings were, your cookie flushings. This is a fundamental manipulation at the network layer, which also is basically the equivalent of like, painting your driver's license, your license tag on the side of a car, and it just stays there for everywhere. So every website you go to gets this unique tracker ID. It took like 8 months for even the basic mechanism of this to be understood. And in fact, one of the carriers actually has a patent on this because they do forced downgrade attacks using some of the same things we saw with logjam, but these are patented techniques, right? So you start an HPS connection, the carrier downgrades it so that they can do this packet injection. Yeah. I don't know if anybody has followed some of my rants recently on VPNs, but if you know, the short version is most commercial VPNs just suck and they lie and they're awful and they lie about, you know, the fact that they suck and stuff. This is for IPsec VPNs. This is a pre-shared secret key. This is the equivalent of putting a server's private key on like a public FTP site, saying go crazy. And these aren't even clever. These are, you know, like the name of the tour guards is tour guard. So one of the first things that happens way before authentication in terms of user authentication is identity. You know, are you really talking to, you know, private internet access or tour guard? Well, this is a key part of, you know, the key material that's put together. And with that, and if you doubt the importance of this, there's, I think, 2 major databases that intel agencies have where they're stuffing this stuff away because it makes man in the middle for IPsec trivial. And it's like every month that goes by, you know, we're seeing some of these ad network hacks where it's not Forbes or Fortune or Washington Post or New York Times, but it's their ad network. But if you dig a little deeper, what it actually is their top-level domain, DNS has been compromised. So what a lot of the mainstream media tends to do when these things happen is they talk about the politics or, you know, whether this faction or that faction of, you know, some group was, you know, what the attribution was. It's missing the point. This is, they've lost control of their DNS. That's a really big deal. I'm not sure if, you know, I think in some cases this is it's like misunderstood resources or something, but I think some of the basic infrastructure is not getting the attention it needs at sort of a core level. I saw this slide the other day, I thought it was great. So client expectation, you know, client budget. Awesome. How many of you remember the Commodia case? Right, so Bank of America with IE, Firefox, whatever, yeah. Certificate issued by Superfish. In real time, you're a low, you know, low in the stack on the Windows box. A certificate was forged for Bank of America in milliseconds, presented to your browser, and you get the little lock. Okay. And the only way that you get the little lock is, by the way, as part of the install process, a root store was modified so that Superfish Inc. is equally as trusted as, say, VeriSign. This is on, you know, the Lenovo laptops. Right, so when it, you know, eventually sort of got down to it, this was a developer kit. I mean, they literally have this like happy cartoon for like product people, like, you know, you install this SDK and you can intercept traffic and network apps, you know, like, okay. And the other thing too, one of the things that the media got wrong with a lot of the coverage of this, if you remove the software, the core trust stores were still there. So it was sort of like someone said, well, you've got Equifax, you've got, you know, VeriSign, you've got, you know, whoever, you've got PrivDog, and you know, get rid of this junk. But the root certificates were still there, which means anyone, and by the way, their private key was on your machine too, and it was basically half an hour, I think, for Rob Graham to you know, get that out and publish it. So to do trivial man in the middle. And I think some of the narrative was sort of around, well, you know, this was just a few kind of inexpensive consumer laptops. How many shops don't do the, you know, wipe the new machine, do a clean install, and you know, sort of these standard best practices? Because I guarantee a lot of people don't. And these things are going to be in the supply chain for years. What I loved was Redmond's response to this. So if you're running Windows Defender, you know, it just yanked it out. I mean, can you imagine, you know, any other piece of software like that has presumably a whole commercial product base where they just say, no, you're illegitimate? I think I saw something too that either today or last night they're doing the same thing on the Ask toolbar, which props to Microsoft.
Yeah, we are.
But trust is complicated, right? So in the 80s and 90s, I think people know, you may have heard of this, there's a number of regulations that were put in place to make it really difficult to distribute crypto software outside the U.S., it was literally classified as a type of munitions. And so there's, a whole bunch of agencies and bureaus and things set up. And to some degree, we've relaxed some of those standards. But if you still look at sort of the core contributors in the early 90s and things, most of them weren't U.S. nationals. I mean, there are some huge notable exceptions, but by the numbers, a lot of folks from the UK, and not as many from the US. So Bureau of Industry and Security, through the US Department of Commerce, this is the government's official policy arm and enforcer of US encryption policy for code, for encryption code, right? So they even have a whole section on guidance for encryption. Yeah, they don't quite get their own encryption correct on their public-facing site, and it's not even close. Not even close. And then we have conversations like this with, folks like Mike Rogers that say, I don't want a back door, I want a front door, huge, big, multiple locks. The problem is we had political compromises of encryption in the 80s, and it's 2015, and we're still feeling the cost of that and paying the cost of that through things like Logjam, where global commerce through VPN, through SSH, through HTTPS is, critically far less strong than it should be decades later. So this is kind of one of my main themes. That we have some issues, some fundamental trust chain issues with the internet, but we're working on it. And by the way, I'm not trying to, by any means, say that encryption is the answer to all of our problems. In fact, it's often rarely the problem. I love this. This is from, I think, 3 months ago in Times Square. It was a big Reuters news board. I don't know if you guys can read that. It's basically saying Windows XP support has expired. That has nothing to do with encryption. That has nothing to do with, like, I think a lot of people in sort of the pure crypto and academic crypto world really underestimate kind of interop gravity. Like, once things ferret into, routers and middleware and things of this sort, that it takes a long time to get that out. And then I don't know if you guys saw this, but I assume most people in the room know about Nmap, right? I mean, it's a crucial tool that many of us use, every week. So they'd had a mirror site on SourceForge for forever, and I don't know if you followed the story, but at some point, I think a few months ago, SourceForge made mirror copies, and they start bundling crapware and malware and things with, well, I guess there's some debate as to whether it was malware, but what I do know is that there's some really nasty stuff, and it had active detection avoidance for things like if it detected it was in a virtualization environment, it shut down. It didn't execute. But I mean, they ripped off the logo. And so there was a period for I think a few days where where the core team in Nmap just couldn't access that site because it wasn't their site. It was a spoof. That's a problem. We're working on it. Oh, so I get this. I got asked quite a few times. I'm just a regular, sysadmin, and I just want some very simple answers on SSL and TLS. Like, it shouldn't be that complicated, right? Okay. Well, when we're putting a configuration together for a public-facing website, and again, I'm not talking about app-level stuff. I'm not talking about mobile API endpoint communication. I'm just talking about sort of traditional vanilla public-facing. So you have to make decisions about protocol, about the cipher suite, about the key exchange, about the hashing mechanism, about the cipher modes, about the authentication. So can you distill this down in like 2 easy slides? What do I just really need to know? I could say do this. In 2015, just do this, right? But I added at the bottom, don't forget, strict transport security, certificate pinning, cert transparency, SNI. Okay. No, I'm just kidding. Don't do that. Don't do that. Actually, and understand your install base, understand your interop requirements, your threat models, and then go read everything by these folks. I mean, there are sort of how-to guides that Mozilla puts together and SSL Labs puts together, which are fantastic. But you really have to understand it. I mean, are you putting together, a photo sharing site? Are you is it your personal blog where you're going to talk about cat stuff? Or are you like really worried about, nation state surveillance? Because those are very different threat models. And do you have to support Nokias that are like 6 years old? Screw them. Well, okay. But then if you're in the commercial world and you have expanding emerging markets, then it turns out that not everyone's running, an iPhone 6 or a, OS X desktop that was updated yesterday. And so it gets complicated. These are some of the top folks in the field. Adam Lange with Google in particular, Thomas Patasek, really follow their work. There's some great resources they put out there. All right, let's talk about the OpenSSL audit. So we got approached about a year ago by the Linux Foundation, and they said, would it be possible to audit OpenSSL in the scope of Heartbleed, or in the aftermath of Heartbleed? And we sort of talked about it, and we said, well, it's a pretty big beast, right? How big is it? Eventually, we came to the conclusion it would probably be one of the most ambitious security reviews in internet recent history, because the thing runs on many dozens of platforms, many dozens of OSs, many dozens of chipsets. There's the whole FIPS module. So I don't know if people are familiar. If you do any work with the US government for system deployment, there's a whole suite of sort of accreditations and things. If you claim, or if you're purchasing either gear or software that claims it has strong encryption, there's a certification process that has to happen. It's painful and it's slow. There's a whole long history behind that. When the hardware DES decryptor kind of sort of broke, people really, CIOs and people at NIST were kind of like, we really need to have some kind of sanity check on crypto. The problem is with FIPS and FISMA compliance, I think a lot of agency people and mid-level CISOs and things, they think FIPS has something to do with security. It doesn't have anything to do with security. It has to do with math being implemented correctly, right? Anyway, there's a gigantic install base. If you're running GovCloud, for example, in Amazon, you have to have FIPS certified endpoints, which means there's a very narrow suite of ciphers and protocols that you can run on your caching endpoints, on DNS and so on. The other thing, and this hasn't gotten much publicity, I think a lot of people know about the Libre SSL project from the OpenBSD team, and they're doing amazing work. But over the last year, OpenSSL is doing a massive refactor. It's probably not completely accurate to say it's a complete rework, but there are some major pieces that are being pretty well overhauled. So what are the goals? What are they asking us to do, and what are we trying to do? There is the analysis piece, and we'll talk about that in just a second. But then there's also, one of the things that we would do, working with the whole group, that's doing this analysis, is there's a giant corpus of certs floating in the wild that people have collected over the years. There's a whole cast of tools, right? I mean, there's countless static analyzers and dynamic analysis, tools and things. We were actually approached by a couple of different companies that basically said, and some research labs with the government that said, anything you want. Any fuzzing tool, any analysis tool, it's yours. So, there are some sort of parallel efforts, but we have kind of a limited number of resources in terms of the engineering hours and the commercial support to do this. But one of the takeaways was we didn't just want to do an analysis, do an audit, file a report, and let it gather dust. What's really useful is we could put some of these things in the public domain and really share some of these tools. So I think a lot of people would approach an arbitrary software analysis with static analyzers. I've tried 3 or 4 different just source lines of code counters, like, just you point at a directory and you give me the number of lines back. And I got everyone gave me a different answer. It gave me a different answer because OpenSSL is C, but there's also a massive amount of assembler, except it's not really assembler. It's Perl that, depending on the target environment, becomes assembler. Why on earth would you do that? Right, I mean, that's my reaction too, like, why on earth would you do that? Because there is 15 plus years of hand-tuned, chip-by-chip optimization and mitigation for things like timing attacks and blinding and things like that. But good luck with most automated tools, even doing that. And there's a fair number of shell script lines and even a little bit of C++, which is bizarre. So you can't do everything, and so we sort of looked at this and talked and worked with the core SSL team and with the folks from ISAC, who are now NCC group, and said, well, let's prioritize this. So what are things that are more stable and less under development? Because there is no there's no SSL version 1.1 mainstream branch. If you do a live sort of nightly checkout, you're effectively getting the 1.1 version, but it's there's still a fair amount of things that are in massive flux. There are some elements though that don't change that much. Although actually maybe in the last week, the X509 and ASN parsers, the cert parsers, might get a refresh, but I don't know. So things like multi-precision integers, constant time blinding. If you know the C world, it's easy enough to get a 32-byte number, but when you start working on these large primes, you're working with data that aren't they're not privileged first-class citizens in the language. So big num is the way to, that OpenSSL does integer math. That hasn't changed a whole lot. I think at last count, Tom and the team put together like 93 million certificates to do, fuzzing and analysis. It's it's a pretty healthy test bed. The TLS state machine, the EVP modules that do, the PKI constructions, the HMAC, multi-key envelopes, things like that, protocol flows, memory management, those are getting more work, and so we're delaying those. We're basically past phase 1. Don't have anything, critical to report yet. We're probably looking at mid to late summer for the last of it to be finished, but there's an awful lot. And OpenSSL is a toolkit, right? It has so many different use cases. We're not really interested in things like RC4 or other constructions or cipher suites. We're interested in things that will be coming in the TLS 1.3 standard and that are sort of going to be part of the modern web. Right, so again, ECC, Diffie-Hellman signatures, these ultimately are the highest priorities we'd like some kind of verdict on. The good news is there's a remarkable amount of stability and well-characterized code. Also, too, just as a footnote, the entire code base, every module got reformatted, and there's now coding standards, and there's some kind of community structural things that are being put in place that make a big difference. But there are all kinds of surprises. Did you know that OpenSSL has an SMTP-aware web server? Like if you go to a Linux distro, you've got its own web server, right? So if you've ever done testing with an S client, there's also an S server that speaks beyond all the other basics you think of. It speaks SMTP. So we're not touching that. We're not touching VAX. We're not touching, early Windows stuff. It's just not happening. And by the way, it's not nearly as aggressive as the LibreBSD work, but the LibreSSL, but there are big chunks that are just getting tossed. So what are some other things that are kind of coming that I think are worth talking about a little bit that should be on your radar? TLS 1.3, so this hit RFC, I think, in December, at the end of December. This is a major deal. With HTTPS 2, which is, sort of finalizing in terms of the structure, HTTP 2.0 does not require secure transport. But if you do secure transport, you must do TLS 1.3 compliant cipher suites, authentication, and so on. Libsodium, I think you're going to be hearing a lot about it. This is a complete rewrite. I think it's been around for a while, but this is out of Dan Bernstein's group in Chicago. You hear a lot on the web about Cha-Cha 20 and Poly 1305. A lot of potential, but until they're in mainstream distros without custom compiling, and that probably won't happen until OpenSSL gets it. And I'm not sure if it's going to hit 1.1, but it's coming. And they give important sort of alternatives and different use cases than some of our existing cipher suite tools and authentication mechanisms. Moxie's work on the off-the-record and the axolotl ratchet, really interesting stuff to look at. This is actually, I discovered this the other day, so I think people may have heard a little bit about Golang, Go. It's getting a lot more attention. It's been around for a while, but some really big organizations are using it. You're seeing it sort of more visibly. But one of the nice things about Go is it's a complete from the ground up, really well done crypto library. But it's not just that. So you actually have in the standard library of Go now an SSH server, an SSH client. You have OTR, you have PGP. Like these are part of the standard library. That's pretty interesting. I think it's probably overhyped a little bit on the container side, but I think what a lot of the media misses is that one of the efforts of the groups that are behind things like Linux containers and Rocket and Docker are limiting the attack surface, limiting the number of processes that are running, and really trying to isolate namespaces in a way that you can have a much higher ratio of active processes per box. I think Let's Encrypt, in the last few days, they've announced that they're sort of beyond a crucial part of their certificate authority reviews, but that's a really great project to take a look at. And then this hit a couple days ago, and I think I'm not sure it got quite the attention it should have. The U.S. government came out and said, by the end of next year, all federal websites and services are HTTPS only. That's a big deal. And I think we'll look back and see it's kind of an important milestone in internet history. I think most people here are probably familiar with the DBIR from Verizon. It's a great model. It's a great resource. I really encourage you to take a look at it. And just a few last things. So, as I said, encryption's rarely the problem. We need to have a much more nuanced conversation about threat models. This business about if only a database were encrypted, then hackers couldn't have done X, Y, and Z. Disk encryption, database encryption have their purposes, but stopping an attacker that's already got AD or root or DBA privileges, I just don't see that as part of the solution. And as I mentioned earlier on the Verizon report, 99.9% of the successful exploits last year were over a year old. That's kind of staggering, particularly given that a lot of the original points of entry and indicators of compromise in the earliest stages were public-facing. You've got public-facing web services that are vulnerabilities that are over a year old. Okay. And then I leave with this. It's, I think sometimes you can look at the reports of the breaches and things and maybe get, a little discouraged. But I would argue that we're in the golden age of web security in the sense of it's still a naive, incredibly high growth period. I think people are getting more sophisticated. I think they're getting a rude awakening. And I think people are finally starting to notice it would be nice if it didn't take 14 million, federal employees, for example, being breached to get there. But I think we are in an enormous period of opportunity in terms of some of the technologies. But we have a number of efforts underway right now to re-examine some of these core stack infrastructure pieces. Things like verifiable builds, things like the certificate authority chain, things like the basic, what is the attack surface that's exposed? What are some of these sort of, crufty underbelly that haven't been examined in any kind of disciplined way? Well, they are being looked at now. So I'll leave you with this. The security trust chain is broken, but we're working on it. I wanted to say special thanks to some of the folks on this slide that really gave me some great input and help and advice along the way. And then I don't know if you guys saw this, but like 3 months ago, I think most people here are probably from the US, but any of our friends from Europe, I don't know if it's the same expression there, but if you go, if you're doing some kind of protest or whatever, and you strip naked and run onto a public field that's called streaking. Well, there was a guy that was streaking at a London rugby match. I have no idea what the point of his message was or whatever, but that was what happened. So be careful out there, folks. All right, and then I'll leave that there. Happy to answer any questions about the audit or the project or anything you'd like. Thanks.